Welcome to Heat Suit Draconis, here be dragons. So, a Mars mission is full of dangers and health risks, but a new research paper from a team of scientists, including researchers from the University of Colorado Boulder, published by the journal GeoHealth, lays out just how dangerous the surface of Mars really is. In low gravity, muscles weaken and bones lose density. And that bone loss can cause kidney stones, fluids to shift upward, reducing blood volume, shrinking the heart, and triggering arrhythmias. Balance is affected too, leading to motion sickness and disorientation. The immune system takes a hit, with the viruses reactivating and defenses weakening. Spacesuits need to stay flexible, but their low pressure brings the risk of decompression sickness. And then there's radiation, intense, constant, and dangerous. Unlike in low Earth orbit or even the moon, a mission to Mars leaves astronauts completely exposed. That means higher risks of cataracts, cancer, lung damage, and even brain injury. Then we have the dust. Martian dust isn't just dirt, it's a serious health hazard. These ultrafine particles are about 4% the width of a human hair. They're sharp, jagged, cling to everything, and they're chemically reactive. Even worse is that they can easily stay airborne in the low Martian gravity. That makes them very dangerous, especially when they get into lungs, eyes, or spacesuits. Unlike Earth's dust, Martian dust contains perchlorates, compounds that can disrupt thyroid function, damage DNA, and weaken the immune system. It also holds nanophase iron, tiny metallic particles that can trigger harmful oxidative stress in the body. Even the red color of Mars comes from this iron. Once inhaled, these particles can travel deep into the lungs, even into the bloodstream. Over time, this could lead to chronic respiratory disease. We've seen similar problems before. During the Apollo missions, astronauts exposed to lunar dust experienced sneezing, coughing, and eye irritation. Mars dust is somewhat less abrasive due to weathering, but it's still magnetic, electrostatic, and chemically reactive. It floats easily, sticks to surfaces, and is tough to remove. And it's what's in the dust that makes it especially dangerous. Martian soil contains toxic components like silica, perchlorates, nanophase iron oxides, and trace metals, including chromium, beryllium, arsenic, and cadmium. Many of these are carcinogenic or cause long-term lung and immune damage. About half of Martian dust is made of silica, much of it in crystalline form. These particles are small enough to evade the lung's natural defenses and settle deep inside. There, they can cause inflammation, autoimmune reactions, and eventually diseases like silicosis, an incurable lung condition as well as lung cancer. Nanophase iron compounds in Martian basalt can create reactive oxygen species, or ROS, highly reactive molecules that inflame and damage lung tissue. Similar particles on Earth are linked to black lung disease. Bacteria also thrive in iron-rich environments, a dangerous mix in space and low-gravity environments where astronauts' immune systems are already weakened by microgravity and radiation. There's also gypsum, a mineral that absorbs moisture and hardens. If inhaled, it can irritate airways, block digestion, and mimic the damage seen in coworkers' lungs. Worse still, the full range of sulfates and minerals on Mars remains unknown. The potential for new, unstudied health effects is real and concerning. Then there are heavy metals. Chromium is one of them, particularly the hexavalent form, a well-known lung carcinogen. On Earth, it's tightly regulated. On Mars, under oxidizing conditions, there's a chance that safer chromium could convert into this toxic form. Beryllium is another threat. Even tiny exposures can cause chronic beryllium disease, a deadly immune reaction with no cure, especially dangerous for genetically predisposed individuals. Arsenic, found in Martian meteorites, can cause liver and nerve damage. Chronic exposure leads to skin lesions, cancer, and neurological disorders. And cadmium, a cumulative toxin, can severely damage the lungs, kidneys, and bones. Inhalation may lead to pneumonia-like symptoms, while long-term exposure raises the risk of organ failure and cancer. Right now, these metals appear in trace amounts on Mars, but the risk isn't just about how much is there, it's about exposure over time. Mars missions will last months, not days. Prolonged contact raises the stakes significantly. In space, medical treatment is limited. During a mission to Mars, help from Earth could take up to 40 minutes round trip, too long in a crisis. There's no quick return, and surface operations will require frequent, long-duration EVAs. Astronauts on Mars will also face immune system suppression from microgravity, radiation, and stress, making them more vulnerable to infection and inflammation. In short, Martian dust isn't just a nuisance. It's toxic, persistent, and unpredictable. Protecting astronauts from this fine reactive dust will be one of the most critical challenges in the future of human space exploration. Before we can walk safely on Mars, we need to respect the dust and be ready for what it brings. Anyways, if you want to read the research paper, I will have a link to it. And have a great day.